Alright guys, welcome to the part number 8 of our videos on formatting the Formatables refactor. I incorrectly called the previous part number 6, but it was actually number 7. It's been a while. So we are stuck at the moment because, well, not stuck, but the current problem is we're generating more file paths than we did before. To recap, what we did in the previous video was we managed to get to the bottom of the incorrect names being generated. We fixed all of those, and then we got to the point where all the names being generated were correct, but we were generating too many of them. And I think what's happening is we have, at the point of generating the file paths at present, we still have a combined logical physical space, logical physical model. And this logical physical model contains everything. So if you imagine when you load up a model in Dogen, to take away a little bit from the detail and give you the higher level picture, when you load up a model from Dogen, it has to load all the references to that model it requires in order to be consistent. So if a model uses other models, and if those models use other models and so on, we need to load every single model. The reason why is because we need to build things like the include paths and so on, and models may do overrides to certain properties. So all these models are in memory for a period of time, and by the time we get to text generation, normally we don't really need all those models anymore. We just need a target model. So the existing code, this is my theory, in the existing code we filter out all of the non-generatable types prior to generating paths, or perhaps we filter them out prior to running the in fact, that's probably it, right? We filter them out prior to generating paths, which means we only generate paths for those types which are actually targets types, and then for some reason we then filter them out from the actual model afterwards based on whether the path is empty or not. So you can see there's just some really strange logic going on here. So what we're going to do first is going to try to prove this theory, and the way we'll do it is by having a look at what let's just look at the workflow of say C++, for example. So this is the chain that's doing all the hard work in C++. We start by creating the locator. We then generate the Formatables model, and then presumably we then apply the transform, which is the actual generation of text. So I think what's happening at the moment is somehow in the Formatables workflow, this is the thing we're interested in. Sadly, we never seem to open the buffers where we want them. Let's go here to the file and path guard. So this guy here is a very simple guy. It doesn't do anything special, but what it does do is it loops through the Formatables model, and it loops through the entire Formatables model. So there is no reason for us to expect some paths to be filled in, some not, because as you can see here, we're saying, give me the Formatables model, and then for every artifact properties, generate the full path. And now I think, my understanding, if I remember this code well, is that the artifact properties are actually a very dense space. They contain every single possible permutation of a logical model type and physical model type. So not every point in this space is going to be a valid point, which would then imply that we must be doing some kind of, so you can see here artifact properties dot, okay, interesting. Right, so we are computing the artifact properties, and oh yes, okay, fine. So we are actually computing every single possible artifact property path, but then, quite cleverly, cleverly in quotes here, quite cleverly, we must only copy things from the artifact properties file path where required. Because if you remember, to make things even more complicated, I mean, this refactoring is getting quite dense. Some of the types we're trying to get rid of, these artifact properties file path, we need to get rid of this guy here. In fact, all of these guys here are going. What's happening at the moment is we're probably populating all of these, but we are only actually copying across the path in certain cases. And those certain cases are going to be only, of course, this is absolutely insane, but that's actually, yeah, exactly. So to recap, what's happening at the moment is this: we are computing every single path across the entire space, logical physical space. So there is, in that sense, there is no difference between the new world and the old world. However, what we are doing is we are only taking the path that was computed for cases where we are actually generating the artifact. And the reason why that happens is because we are populating the path, as you can see here, only when the assistant kicks in, and the assistant only kicks in when you're generating text. So we could do exactly the same thing here. We could instead of taking, in fact, to be honest, we could probably prove that this theory is correct very quickly. So what we need to do is we need to this might be a very simple exercise, in fact. That's just a simple fix. That's the debug here. So now that, actually, to be honest, let's not do it here, but let's do it in here, in this area. And what we're going to do then is we're just going to look for the legacy path transform, and we're going to say populate the old fields, and then as you can see here, not entirely clear why we're having a problem. Right, so now then, what we're going to do now is going to say we're going to replace this crazy logic that we got here with some similarly crazy logic, which is we're going to say obtain the file path from the artifact. In fact, we can't call it artifact, I don't think. We have to call it artifact. And then this will have path properties, and this will have a full file path. And so what we've done now is we've done a similar logic to what we had before, which is take the path only for those cases where we're actually going to generate, so that the rest of the crazy logic that we got, the filters on empty file paths, will still work, hopefully. However, for this to really work, we probably need to repeat this craziness in C# as well. Now this is clearly none of this is ideal, but one must bear in mind that this is just part of the cleanup code. So we are just trying to move from one step to the next. Clearly not there. So if all of these theories are correct, this should then copy the file from the new location, copy the file path from the new location instead of the old location. And then if the path had been computed correctly, none of the files will move. Right, so they have not been computed correctly. Let's have a look. So perhaps our grep was not quite right. But still, we're moving forwards. So let's have a look. What kind of errors are we getting here? Interestingly enough, we're not getting as many errors as one would expect. So the grep probably was correct, because you see here the errors that we're getting are all in test models. And let's see if there's anything special about these test models. Right, so we failed to generate main.cpp on the core model, that's fine. And the boost model, we failed to generate test files, main. and test files. Okay, so the pattern seems to be that we are not generating tests correctly, and we're not generating main correctly. So we probably could do a quick check at the moment. This is a remove. Right, so you can see clearly here what's happening, right? We are not adding the src to the path. So we can fix that quickly. And for the test files, let's have a look at where these guys should have gone. So if I just have a quick look at the C++ ref import and the boost model. So here we are. There we have some generated tests here. And according to this, I would expect to have seen something on source. Oh, interesting. So the generated tests right, so we are a bit all over the place really. So for the ODB feature facet, we're not generating the proper path with src. However, for the tests, we are generating the path with src where we shouldn't have. Okay, it's interesting that we managed to scramble things that badly. Right, okay, I think I know what the problem is. The problem is that we are mixing. So let's just go back to the legacy transform again. Right, so let's start with main, for example. So, here we go. So we're basically saying that main always goes into tests, which is not right. Right, so we have the first problem. We need to distinguish between the two different types of main, because one main will go into test, the other one is going to source. Let's try to solve that problem. Seems an easy enough problem to solve. So let's have a look at the different archetypes. In fact, this is going to be a bit of a painful thing because we only have the archetype name, which is a simple name. So perhaps what we'll do is we will attempt to match on the archetype name. If that fails, we'll attempt to match on the full archetype name, because this handles like 99% of the cases, and then we're going to have a few straggling cases that don't really work. So or perhaps we could just have a different function, get archetype kind by full archetype name, and that will then match a few. Not always the right thing to do here. But to recap the problem, we have two archetypes, a main inside of types and a main inside of tests. And this is perfectly normal, this happens all the time. The only slight problem is, in this old world, the way of looking at things, these two archetypes, they require different paths because they belong to different parts. So what the meta model now explains is that a project is composed of parts, and things belong to parts. In the old world, we didn't have that notion. So what's happening at the moment is that we have to choose what part something goes in. In this particular case, it went to tests instead of going to types. So, but of course, because depending on which archetype it is, it will go in a different part. We can't just hard code it. We need to at least check the full archetype name to figure out what's the right part. That will solve the problems that we're having with main. That's not a big problem. While we're here, let's just have a quick look at what we think the problem with tests is. We seem to be putting the tests archetypes as part of so let's think about this. Let's imagine I'm tests. So there's a tests C++ main. Oh, that also looks very strange. I'm not quite sure what this is, but again, this also looks very strange. Why are we returning? Clearly we done something temporarily here and we forgot about it. Now what we need to bear in mind here is that there doesn't seem to be a lot of handling for tests. We would expect to see some archetype. So let's think about this. Yes, so similar problem really. As you can see here, so we got exactly the same problem. So for class implementation, class enum implementation, so everything that goes in the tests, we need to filter out by full name really, and then those have to go on the right parts, which means that hopefully, to continue our hack, hopefully what we're going to see is that there is different kinds. Yes, test C++ implementation and test C++ main, all these things are different. So what we need to do then is we need to basically say, if your tests, this is probably a better hack, if you're part of the tests, then we will do you first, and then if you're not, by full archetype kind that is, and if you're not, then we'll do you afterwards. So what's the best way to do that? It's not obvious that you... Oh, but facet probably will be tests, presumably. So if I look at test.cpp, the facet type is tests. And that's the only case where this happens. So we could say, if the facet is tests, do one thing. If it's not, then do something else. I mean, I don't think this happens anywhere else. Because pretty much every other facet will go in the same parts. So test is the only special case. Okay, so the quick and dirty hack to do here is to say is tests. You just need a boolean here. When we're doing the get archetype kind, we just need to know if we're tests or not. If we're tests, then we're going to return one thing, and if we're not, then we're going to return something else. However, yes, and yes, exactly right. Even though we don't really need all of this stuff, but it doesn't really matter. So let's just do something really simple here. Let's just basically say, yes, this is a really good idea. Well, really big hack, but really good idea. So we just need to hack. Hold on to the region artifacts by archetype. We need a physical name somewhere. Here we are, a.meta name. So here we have a meta name, which is then sent to this guy here. Right, now then, so in here, so if an.facet, not sure. Okay. Let's just, this sometimes happens to LSP, not sure why. Seems to get into a bit of a state. You kind of need to open and close the document, and then everything seems fine after that. Right, so what we're trying to do then, we try to say something like if now we don't really want the AN to be fair, we want the PMN dot facet location dot facet perhaps. I think the problem in this case is sometimes is that you need to bring in, well, let's just double check this is not not entirely sure why I can't see location. I wonder if sometimes the problem is that you require to bring in the definition to the header file, and LSP doesn't really give you very good inkling as to why that is, what's causing the problem. It's also slowing down quite a bit. Normally pretty quick, especially with the latest version of LSP. So, oh sorry, I meant identification, of course. So let's just try then to bring in the identification for the physical meta name. And hopefully that would, yes, okay, so see, this is, it's a bit annoying with this kind of errors. It'd be nice to basically say, oh, type, I haven't got the definition for the type or something like that. But no, it's not quite what you get. So if we say something like this, perhaps even constable is tests, something like this, right? And then if we could here say something like constable is tests. As you can imagine, this is all very quick and dirty, but it doesn't matter. So it's temporary stuff. Hard to remember that sometimes. Right, so if we're tests, then we need to do this for a couple of cases where we just need to say something like is tests, and then we return the header for the tests, otherwise we return the other one. And then hopefully now go to physical. So tests dot, there must be a test dot header. Oh, in fact, to be honest, I don't think we have test dot header. We have main and we have implementation, but not header. So I think what we'll do is, for this particular case, is we'll just leave it as it is. Don't think it matters really. But for the implementation, we shall check to see if we're tests, and if it is, we will return different methods. Similarly, for so as you can see, the CMake lists, we have different. Quite interesting. How exactly do we distinguish between them? Yeah, that's probably not going to work really, because oh, actually by sheer luck it works, because the names so this is really not a very good thing. So what we've done here for the CMake list case, there's a lot of modeling errors really. For the CMake list case, you see there's a CMake list class here, and then we have in the build facet we'll have CMake list with different names. If I could find it. There we are. And so really, in theory, this should really not have well, it's not very clear exactly what we're doing with these types, but fine. As it happens, this works for this particular case. So we're not going to bother with that. What we really want to do is to make sure that main. Right, here we are. So in this particular case, we want to say if it's tests, then you can return the tests main. But if not, please return the C++ main. So I think with this we've covered. Ah, okay. There is no C++ main. It must be something like C++ main. Oh, okay. So if there is no C++ main, we probably could get away with just returning C++ implementation, really. And now let's have a quick look at the madness that is this rest. So if it's MS build, returning, well, I think I'm just going to leave this as a fix me for now, just to, we just have to try to confuse one issue at a time. So at the moment we're more focused on all these guys here. So let's see what that does. No, not going to do anything because we forgot to use the flag. Now, it's not necessarily the case it's going to fix everything in the world, but hopefully this will redirect the test to the right places. And the result was, yeah, it did. So as you can see here, we are now managed to fix the problem with tests, but now we have problems with ODB, which is a facet. Now I think well, first let's just have a quick look at boost model. So C++, right, in these cases we seem to be missing source, but generated tests though, in generated tests we seem to be missing the prefix tests. How are we doing for time? Let's start with ODB. Why is it that we're not putting the ODB, source ODB? So these are just plain, interestingly enough, right, now this is peculiar. Why do we have so many main ODBs? That's actually a bit of a problem. It's not so much the fact that we didn't put the source in it, but the bigger problem is we seem to be generating the main file across all sorts of places, right? So I don't think there is any main in boost. Let's have a look. If I look at the models we have in the test model, test product, and open up the boost model, I don't expect to see main. There is a main. Oh yes, there is a main, of course, now I remember this. Okay, so the reason why there is a main is because we want the main to exist for tests. And so we put the main in the logical representation, and then via the profiling, we determine what facets are enabled. In this particular case, only testing is enabled. And then we don't really want, so if you remember, we're projecting a logical element across physical space. We want to project specifically just one facet, not to all facets. And configuration is enabling, it's doing that for us. So somehow, when we put this new code path, we are now projecting to all facets. Because you can see here, we have ODB package 1 main, which is already interesting because we seem to be projecting to a different module. But more importantly, ODB main, generated test main, ODB main seems rather identical to the first one. In fact, we have 3 times the same. Most peculiar. Oh, this is very, very puzzling. We wouldn't expect to be generating new artifacts. Now this one is perfectly correct. We seem to basically be missing the tests. Oh no, this one here, the tests postfix. So that we understand. Every other one is not so obvious. So we see. Let's just make sure there is no other main here. Like there is no main in package 1. No, there is no other main. So it seems that the projector somehow is projecting this into all sorts of other places. There shouldn't really be. And if we look at all these errors that we're getting, they all seem very similar. We seem to have main. Okay. Just before we go any further, isn't this just a simple case of a switch gone wrong? Excuse me. I wonder if we are somehow not returning where we should be returning, for example. It seems very strange that we are generating so many of the same, if you see what I mean. Lots and lots of artifacts with exactly the same name. Very puzzling. It seems like a really bad bug. The assistant is always taking the path property, so that can't be the problem. So it has to be when we generate the artifact. So somehow, what seems to be the case at the moment is we are generating. So I think we can probably get away with removing this now because we don't need that anymore. But what's happening at the moment is you're generating an artifact, and the logical name of that artifact is kind of lingering and being used for other artifacts. Now, why that would be the case is not obvious. I mean, we probably could just there's no need to have a variable here. Yeah, let's try to think about this. So what's happening then? Okay, it's probably not quite right. We should say file path. Okay, fine. Just keep it as it is. Perhaps these are all really not that important things, but the OCD in me always has to struggle with these kind of things. Right, that seems a bit more logical to me for some reason. So then, what's happening here? What's happening here is that we seem to be somehow processing the previous element or the next element, something with the name of the element is lingering, and then when we go to name the next element, we seem to be giving the name of the previous element. That would explain why we have so many artifacts. As you can see in the compilation, we're having a lot of artifacts with the same name. That could happen if once we process one, then we start taking that name. So, and then why would that be? Well, let's have a look at this main.cpp. Wow, is main being processed? Because that seems to be the clue to this problem. So we're basically saying here that if the archetype name is main or ak, then if your tests, then return C++ test main, otherwise return the implementation. Okay, that looks innocent enough to me. Now we do also have these random things where we are, oh yes, okay, right, that would explain why. If you remember, we left a whole lot of things here as fixed miss because we didn't know what to do for them. I suspect that's probably what's the problem. Right, now then, so the problem for these guys here is we needed some type for it, and we were lazy at the time, and we never made a type. So I think we can do that now. So interestingly enough, we seem to have, no, in fact we do seem to have some types. So let's see what happens if I do something really simple like ms build, and in here let's see if I do something simple like db. See how much of a change that would cause. One of the problems with coding something quite as complicated as this, but doing it in your spare time and doing it when you got time, is that your brain flushes the cache all the time. So you keep forgetting what you've done a few days before. I mean, it's not an excuse really, but it's just a characteristic of this kind of work, really. Right. So now then, we now have a problem with tests, and the tests. Now we know this guy. We know what the problem is with this. We seem somehow tests.main. We don't seem to be taking into account. Right. So the problem here is when we're making a test.main. Right, so what we need to do now is we need to try to understand how the tests.main facet, because there must be some hackery going on here. This is what we always discover when you try to do these kind of refactors, is you refactor. As you refactor, you start to remember all the dodgy hacks that you did just to resolve a problem quickly. And it comes back to bite you. Now, there's no override to the file path directly. So the question we have to ask now is, what is the whale template that goes along with this guy? And this guy here will probably give us some clues. So, no mention of the whale template there. We know we are an archetype and we use the test configuration. So let's have a look at the test configuration. There we are. The test configuration has a whale template of artifact transform implementation. But more importantly, full path for test CPP implementation. And this guy is calling right. So as you can see here, in reality, we made a change there. We were just calling the wrong method. Okay, that seems to have resolved some of the problems. Now then, we are down to C# problems. Well, let's start by fixing the easiest of them all, which is, it seems like the extension should not have a dot in it. So, what happens if we remove that? So the focus of this video will hopefully just be the fixing of the full path generation. We won't be able to go very far. Okay, that's all half of our problem. We won't be able to go as far as removing the old legacy transform here, because it also does the header guards and it also does the include, so we can't just remove everything in one go, sadly. But perhaps we can actually just stop populating the locator based. Oh no, actually the header guard uses the locator as well. So sadly, these refactors are quite slow. They're quite fiddly. Right. So now then, let's have a quick look at C#. Integration will do. So what type are we looking at? C# model. Ah, okay, interesting. Right, okay, now we have a problem here. There is no such thing as source and CPP in C#. So we need somehow to distinguish between the paths that we're making. Oh, then again, having said that, we did have a make full path for C#. I think so. I think the problem is, well, first let's make sure that we are indeed using the make full path for C# for the C# things, could just be the case that we're using the wrong function. Vaguely looks correct. Let's have a look at the error message again. It seems to be all over the place. Dumper and... Right, so then, okay, that being the case, the question then is, why is this guy relying on the parts? So this is just the full path to the implementation directory, so presumably this is the problem. We don't really want the full path to the implementation directory. We would like, presumably, the project path. So if we just start off by saying, well, I think that would probably do just nicely. Right, so now this guy is now saying, please locate the project path. And in this world where there are no, where it's not data driven, it's hard coded, you need to basically make sure you call the right things at the right times. In the new world, you declare parts and you associate parts with the elements. Okay, so that improves things slightly, but did not quite resolve our problem. Surprisingly. So now then, let's see. If I take C# ref info C# model, that looks right. Dumpers. Okay, I think the problem is how the postfix are being handled. C# uses different way of handling postfixes. So where do we create? Right, I think in facet path we need yet another quick hack. What we'll see here is postfix somewhere. Right, there we are. So if there are elements to append, we are appending them via by adding the underscore. Clearly that's not what C# expects, so that's not going to work. So we could probably just have a default postfix. So we could either say whether you're C# or C++ and then determine what postfix joiner, I guess, to use, or we could just apply the postfix. In either case, we need something that goes into this method that tells us about it. So let's see how badly this is going to break things. We use this a lot. In some cases we use facet path temp, still not quite clear why, but we're going to leave that as is. Let's just have a look. Okay, so tests seem to be our tests and source make lists. Okay, so what is the least amount of breakage we can create here? Well, we're going to go for the boolean. What would be the right name for the underscore? The underscore is joining... Well, actually no, I'm just going to say constable is C#, because this is just a temporary fix, and for now all we need really is to identify whether it's C# or not. So then we can just set that to false, because that's 90% of the cases, and then say yeah. And finally, to complete our lovely hack, we can say here Max seems to have frozen for a few seconds. So we can say something like if not is C sharp, you add underscore 3. Now you can see this is very not exactly the kind of production ready code that you normally put in, but remember this is refactoring to get us to the right place, so it's not that important. It's important that people realize this is really how coding really works. Is continuous refactoring. You keep changing things until you get them to the right shape. So sometimes the intermediate results are not brilliant, but what matters really is the final result. And now we could say true is C sharp. Okie doke. So now then, we only expecting to add the underscore if we C sharp. I think we might still have a problem because I think the namespaces are using, the modules are using a temp function, so I might see a few broken ones still. And lo and behold, that's exactly what we're seeing right now. So we need to extend our hack to the already very hacked temp function. And the temp function just needs the exact same logic. We should really get to the bottom of why it is that we have a temp function, to be honest, but this is all code to be removed. There's not enough hours in the day, so if we just supply const bool is C sharp, and now we just have to see oh, interestingly enough, we don't seem to be handling postfixes at all here. Okay, ODB. Well, ODB is not a big problem, so that's fine. So we don't really care about ODB. These are handled correctly, and that's about it, really. So our theory was interesting, but it doesn't seem to hold true. Right, let's just very, very carefully try to understand what is going on here. Just make sure we're okay for time. Make sure there is no one chasing me. Watching my mobile phone seems to be dying. Quite looking forward to the new series of Linux phones that are coming out. As soon as they are decently priced, I'm going to buy one. So let's just reply to these messages. Right, so what are I trying to do then? We're trying to understand how on earth that underscore got placed in there. So it seems very logical. It seems like we have two methods. One is make facet path and make facet path temp, and we just needed to put the underscores in two places. But in reality, there are no underscores in the temp. So what we probably need to do is to try to look a bit more carefully. Okay, this is an assistant. Right, let's just try to perhaps diff this these guys here a bit more carefully. So, okay, the interesting point here is in fact that we are using CPP. So somewhere, right, so let's just unwind that change there in the temp. That was a great theory, but as Feynman would say, it did not, the facts contradicted the great theory. So now then, let's take something like assistant and see. Okay, so assistant gives us a C# implementation, which one would have thought would be fine, because the C# implementation would go via this path. So that actually looks sensible. However, if I look at interestingly enough, the problems seem to be on directory settings. Yes, okay, so maybe this is a problem that's specific to override. So let's have a look at directory settings. So in directory settings, I would expect the C# backend. Right, here we are. So we seem to have a special case in directory settings, and that special case is we did an override. In fact, that's exactly what it is, isn't it? We did an override to the directories for C++ and for C# as well, actually. As you can see here, the directory is called C# backend. That doesn't seem to have been reflected in the names here. That pretty much is the only thing I think that's wrong with these names. It should have gone. No, and also, of course, we seem to be using the old C++ directories. So, two problems here. First one is we didn't look at the right directory for the backend. That would have been the project directory. And the second thing is we seem to be using the part component of the name. Now, it's not clear why we do that for C#. It's really not clear at all, because C# elements, it's as if there is something that's happening prior. In fact, that's what it is, isn't it? Something that's happening prior to determining what path to use. Now, what would that be, I wonder? So clearly we must be going to make full path for C#, right? And that seems to be the case. We're taking the project path, and then we are taking the facet path. Well, clearly this will not result in that path, because there is nowhere we're adding the component. So we are not actually, the conclusion is that in fact we are not going via the make full path for C# for these cases. So for whatever reason, whenever the directory settings change the project path, something really bad happens. And let's have a look at what that would be. So we have the project path and we have the output directory path. And there must be some kind of computation taking place here in the project path that takes into account pretty much everything. So let's just have a look very carefully at what's going on here. So we start off with the output directory, that's fine. Then we take the model modules and we join them all together. That just basically means the names, the different names of the model, like C# .impl something, directory settings, which get joined together. So up to that is fine. Then we take the project path properties from the model and determine whether the backend directories are enabled. If the backend directories are enabled, we look for the backend itself and we obtain the directory name for that backend, and then we add that, and that looks quite good actually. That means that in the C# case we would have gone all the way to the backend directory. So I think we have a bug in the way we're populating backend directory, because you can see here we seem to think that the backend directory for C# is CPP. So there are two bugs in effect. The first bug is the directory for C# is CPP, which should have been CS. The second bug is it should have been overridden, and it should have been overridden to C# backend. And once we resolve those two problems, we resolve it. So let's think about this for a second. Where is this all coming from? This is all coming from the changes that we've done to the physical model. How are we doing for time? Rushing an hour, so might not be able to get to the bottom of this. But so we had these features here, one of which is going to be the backend directory. Right, here we are, the backend directory. And in here, as you can see, there's an override for C#. So one would have thought that when we're processing this specifically for C#, we would get the override. And this would be under mas.backend. So this is the template expansion over the backend, correct? And this will give us the override CS or CPP. Now, that's not happening. So what we now need to do is we need to go back to the model properties, transform. Actually, not the meta model properties transform, but presumably these are the model properties, I think. Let's have a look at the physical model. Meta model properties, apologies, that was correct. And now let's look at the backend properties. Seeing some funny noises from downstairs. 1 second, please. Nothing happening, it seems. Right, let's think about this for a second. What seems to be happening at the moment is that the backend properties for the C# model are not correct. So, presumably, right, there we are. So get text content or defaults for the directory name, backend ID, BP. Right, so what we'll do is, this probably doesn't really require the usual amounts of creativity. We're just looking at the default value, so let's just look at any of these logs, even if it's an old log, and let's have a quick look for, right, there we are. So these are the backend properties. So if I just take you these guys here, so as you can see here quite clearly, mas.c# and the directory name is correct, and C++ similarly is correct. We don't have the overrides there, to be fair, but we probably will have to look in a minute to make sure that the computer directory names are correct. In fact, to be honest, let's just keep going here a bit more to get to the bottom of this transform. There's a lot of things. In fact, unfortunately, we don't really do a dump of the transform, but to be fair, again, we can rely on old data. So let's go up to tracing. Let's see what tracing has to say about physical. Well, this is a meta model transform, so perhaps part of bootstrapping. No, this is actually not it. So bootstrapping chain, MetaModel production, MetaModel assembly. Ah, yes, because MetaModel properties are in fact done not at bootstrap time. It probably is somewhere around here. Meta properties. Okay, MetaModel properties. Where is that in the chain? It should be. I would have thought it would be in the post-processing chain somewhere, but clearly not. MetaModel properties transform. There we are. It's part of the model population chain. Right. So then, here we need to look for the logical stuff. And around here, we probably do the model population chain. Right, finally, the model population chain. No, well, to be honest, what we really want is the MetaModel properties. Right, in here, we can just JQ the whole lot. Probably not the wisest thing to do, but as usual. We really only care about the model properties, but I think what we're going to find out is that the problem is related to us picking the wrong backend. Locator is probably looking at the C++ backend instead of the C# backend. But first, let's just make sure that the right values are being populated. Right, so what we're going to do for a second is just to try to organize this a little bit. Right, now we need the MetaModel properties. Things are a bit slow at the moment. So we probably have something like, yeah, MetaModel properties. And quite literally, we just need the backend properties. This should be quick. So you see here, the computer directory name is populated as you'd expect. And so it is here too. Okay, so this all looks very good. I think now the key question is to ask the locator, the legacy transform, whether the backend properties are being used correctly. Oh, and here immediately you can spot a problem. We only have a project path. We really need two, because we could have a C++ project path and a C# project path. So we seem to have two problems really. And the second problem probably is we are not taking the computed name from the backend properties. Oh, we are. Interesting. Right, okay, so to summarize, the problem we have at the moment is, let's just try to write this down so before we lose the plot. So locator assumes a single backend. In reality, it could be either C++ or C#. So we need multiple project directories depending on the current backend. Okay, so that explains the first problem. What is not very clear is why we see the name CPP there. Oh, and it is clear. The reason why we see CPP there is probably because we're in C# and the override. So if we were to look at the diff again. So we seem to only be having diffs on C#. Now this could be luck. No, it's not luck. It's actually just we are in C# model, and there is no override for C++, so that's fine. Okay, so that's all perfectly explained then. So all we need is to make sure that the project directory is respecting the current backend. So in order to do that, what we need to do is, unfortunately, we would have to compute two project paths, not just one. So this is actually going to be a bit complicated, actually. So given that we already are an hour into it, we're not going to be able to finish it in this part. So what we're going to have to do, I'll summarize this for the next video. What we need to do is to make sure that the locator can compute a project path that's sensitive to the current backend. At the moment, it's just forcing C++ because we copied this in the locator in C++. But it should really check whether we're in C++ or C#. So it's actually quite a quick change to do, but unfortunately we're running out of time, so we can't do it in this video, so we'll do it in the next video. Thanks for watching.